Hello to all the Form 5 students, 5S2 and 5S4 students. Today I would like to teach you on the first principle for self-practice 2.2. So I have actually discussed what is the method for finding dy dx, or we call as the first derivative, right? So you can call as the first derivative, or you can say it is dy dx, or you can call as find the gradient of the tangent to the curve. Gradient of tangent to the curve. So in short, we have to know how to use the first principle to find the first derivative. So in my previous video, I have discussed with you how to use the concept of limit to find the first derivative. So today you have to do a few exercises in your book B. Okay, so the exercise that you need to do are all the exercise that I'm going to discuss for question number 1 and question number 2 and number 3. So let's have a look how to solve this type of question. For example, I'm going to show you a few examples before you do in your exercise book. Alright, so let's have a look for number 1A. So for 1A, okay, let's say I say find dy dx using first principle. So you cannot use a formula, okay, for the function. I knew that some of you have learned this formula. Maybe you went for tuition, right? So you do dy dx and you just apply the formula, bring down the power, times with the a, times with the x, and minus 1. Okay, this one is using formula. But now the question is asking using first principle. So as I mentioned earlier, when the question say using first principle, you have to use a concept of limit. So please do not use a formula. You can double check your answer using the formula, no problem, double check. Okay, now I'm going to discuss number 1. Okay, let's see number 1. We are going to find the dy dx, so we have to follow the step. Step 1 is you have to find the delta y. So how to find your delta y is you have to, this is the function, you have to substitute x plus delta x. Okay, so still remember the formula, minus fx. Okay, please write down the formula if you've forgotten the formula. Alright, so we are going to substitute the function. So this is your fx, actually y is the fx equal to x, right? So we are going to write like this. Okay, we are going to write f. Okay, let's substitute directly. Our fx is x, right? So it's x plus delta x minus x. Okay, so how you get this is you substitute x plus delta x into the function, follow you substitute x. Okay, so now we can simplify, right? So I'm going to simplify my delta y is x plus delta x minus x. Bear in mind that delta x is just a small changes of x value, is a value. It doesn't mean that delta times x, okay, it's one value. So it's one value, again, is one thing, one term. So you can minus out this one. So delta y is equal to delta x. Okay, what is our first step? Is finding delta y. What is our second step? The second step is, if you recall back, I teach you in my previous video, we have to divide by delta x. we have to find the value of delta y over delta x. So if I divide by delta x on both sides, I will get delta y over delta x, which is 1. Okay, what is the step 3? So let's proceed to step 3. The step 3 is, okay, I write here. Okay, the step 3 is I have to, okay, I have step 2, I have to proceed to step 3. We have to apply the limit. So that is actually dy dx. When you apply the limit, okay, for delta x approaches 0, right? For the delta y over delta x. So you just look at here, this is 1, there is no delta x. So that means dy dx is actually equal to the delta y over delta x, which is 1, which is not affected by delta x, even though delta x approaches 0, is still 1. Okay, so that is how you find the first derivative using the first principle. Got it? So there are 4 steps, right? So this is step 4. So remember, there are 4 steps: step 1, step 2, step 3, and step 4. Okay, let me show you another one. So I have shown you this one. I would like to show you the one with the negative, which is a bit confused. So let me show you C. Okay, delta y is f x plus delta x minus the fx. This is the formula, okay, or the concept, right? Now I'm going to substitute x plus delta x into the function. So let me write in red color pen so that you can see I substitute, okay, x plus delta x, and then I'm going to minus the fx itself, which is this one, which is actually negative. Okay, make sure we put a bracket because you have a negative, right? So this is how you do. Alright, now after that we need to simplify. Let's see. We have negative 4x minus 4 delta x. Minus minus become plus, right? Okay, you got it? So now this is actually plus. Alright, so you notice that normally it can be cancelled out like this. So left only negative 4 delta x. Alright, so the next step is you have to find your delta y over delta x. This is step 1 done. Then step 2 is you have to find delta y over delta x. So you will get negative 4, you can bring over to be divided, or you divide by delta x both sides. So finally the step 3 is you have to apply the limit. So you just write dy dx is equal to limit when delta x approaches 0 for delta y over delta x. So it seems like limit delta x approaches 0 for negative 4 is still negative 4. So it also means that the dy dx is equal to negative 4. Alright, this is number 4. Step 4. Okay, understand? So now I'm going to discuss one more, which is a little bit challenging, which is the one with a negative, normally a bit challenging like this. Okay, so let's do it carefully. I'm sure if you do it carefully, you will get the answer. So basically the first step is find delta y, and the concept is you have to plus the delta x, and then you have to minus the original function. So let's refer to this function. Be careful, you have the negative and x plus delta x, okay, square, okay, minus, make sure you put bracket, fx itself is negative. Okay, that's how you write. Okay, now we need to be very careful when we come to terms like this involving negative. So I'm going to expand carefully. X squared plus 2x, then delta x we make it in the bracket so that we are aware it is one term, plus the delta x, the whole thing square, and close the bracket, and plus x squared, right? It's minus and minus, so it becomes plus. So be very careful when you do. So after you simplify, we are still having delta y, negative x squared minus 2x, delta x minus delta x squared plus x squared, right? Now after that we have to simplify. Normally this term can be cancelled out, so delta y left 2x, delta x minus delta x squared. Alright, now you need to divide by delta. You need to divide by delta x, the next step, right? So step 2, you have to find the ratio. So every term you divide by delta x, and then you simplify. Let me proceed to the delta y over delta x. I'm getting negative 2x minus, I cut one of delta x, right? So now it seems like very simple. So now you can actually apply the concept of limit when delta x approaches 0 for the delta y over delta x is actually negative 2x minus, when you substitute this one is 0, right? So finally you can say the dy dx is actually equal to just negative 2x. Got it? Okay, so that is the answer. So we have reached step 4 here after we apply the limit at step 3. So this is so-called finding dy dx using the first principle. Alright, so I think you can try on your own for the question that I asked you to do. So I'm going to discuss question number 2. So for this one, you need to do in your exercise book. So the instructions given, y equal to 2x squared minus x plus 7. Find dy dx using the first principle. So step 1 is find delta y. So we will actually take 2x plus delta x square minus x plus delta x plus 7 and minus the function itself, right? The function itself, I think we have to use a bracket, okay? Because if you didn't use a bracket, you will make mistake. So make sure you prepare like this. Is 2x squared minus x plus 7. Alright, so the delta y is actually fx plus delta x minus fx. Remember that? Alright, so now we need to simplify to the simplest form. So let's do it carefully. So we have 2x squared plus 2x delta x plus delta x squared, right? Then we have minus x minus delta x plus 7. Okay, minus 2x squared plus x minus 7. Be careful with the sign. Okay, so let's try to simplify. So we have the 2x squared plus 4x delta x plus 2 delta x squared. Alright, so we can cancel out minus x and plus x cancel out. Okay, we have the 7 plus 7 minus 7. The balance is we have this one. Let's copy down this thing, minus, and then we have the minus 2x squared that we will cancel now. So it seems like we can cancel many terms. the function itself cancel out, right? Alright, so now the delta y become very simple, 4x delta x plus 2 delta x squared minus, we have one more, minus delta x. Right, okay, now the next step is to find the ratio of delta y over delta x, which is actually the gradient. So you can do like this, you can just divide one by one, term by term, like this, like this, like this. Okay, so you just divide. So you can cut 4x, you can cut one of these, become 2 delta x, and you cut minus 1. Finally, we'll apply the concept of limit for delta x approaches 0. For the delta y over delta x, you will get, we will get, there is a plus here, we will get 4x minus 1, right? So that is actually the answer for dy dx is equal to 4x minus 1. Alright, so that is how you solve the question 2 using the first principle. Okay, make sure you do it carefully and make sure you double check and you follow the 4 steps. Okay, so we have one more question I'm going to discuss with you so that you can refer if you are not sure. Okay, so by using the first principle, find the gradient function. Gradient function is means dy dx, alright? So for this one. So okay, we are going to find the dy dx using the first principle. So basically the first step is delta y equal to fx plus delta x minus fx. Right, so we are going to substitute 3x plus delta x minus x plus delta x square. Okay, and we have to minus fx. Make sure you put bracket for 3 plus x minus x square. Okay, now let's do it carefully for the expansion. Delta y is 3 plus x plus delta x minus, okay, you have to be very careful for the expansion, right? Like this, minus 3 minus x plus x square, right, plus the x square. So we are going to double check which one can be cancelled out later on. Let's try again. So we have 3 plus x plus delta x minus x square minus 2x delta x minus delta x square minus 3 minus x plus x square. Okay, let's see which one can be cancelled out. Be very careful. When you cancel out, we have many terms that can be cancelled out. So let's see, we have, okay, we have x, we have 3 and negative 3, we have x and minus x. Normally the function can be cancelled out, right? So finally we have the balance of this and this and this. So delta y is delta x minus 2x delta x minus delta x squared. And step 2, we have to find the ratio of delta y over delta x. So we just divide by delta x, divide by delta x, divide by delta x for the, okay, delta y over delta x, you get 1 over 2x minus delta x. This one you have to cancel one of them. This one you can cancel. This is 1, right? Okay, finally we will reach the step 3, whereby we have to apply the limit when delta x approaches 0 for delta y over delta x. So you will get this thing 0, right? For finally you will get 1 minus 2x. And then this is actually step 4 is your first derivative for the gradient of the function. Okay, so the answer is just 1 minus 2x. So in short, for the first principle, you just be very careful when you do, and you must always double check, and you have to follow the step, okay, step by step. Alright, so after you follow the step, you just double check. I'm sure you will get the answer easily. So that's all about the homework for today. So please do it carefully and always double check your homework before you pass up to me. Okay, that's all for today, and I really hope that if you're really not sure how to do your homework, this video can help you. So bye bye and have a nice day.